Hi, we're the Green Gas Team. I'm Jack,
And I'm Max.
and this is our project. So our project initiated from research that Dr. Soy's been doing for the last couple of years, specifically in Montana and cattle fields in Oklahoma. And in his research, he's been collecting different data, including greenhouse gas emissions, methane flux, soil data, as well as NDVI data. And he's been collecting this data through the use of instrumentation towers, so just a single tower system that includes all of the instrumentation used to collect that data. And shown here, this is the one in Montana, and this is the one in Oklahoma. And Dr. Soy sort of came to 508 with the project of taking his existing system and making it portable, just to be able to see, does that data change from field to field? So taking it from pasture to pasture, how does that data change? And the idea came of putting it on top of a trailer that could then obviously be towed by a truck. And with that, so then our project at the heart of it was taking an existing system from Dr. Soy and putting it onto this trailer shown here, which is ultimately the trailer that we have behind us and we use. So one of the big clarifications we made early on, just in reference to our scope, was how we were not going to be responsible for selecting the instrumentation on the tower, and we were only responsible for the design of the system itself. And so that includes your leveling and also just the functionality of that system. But the main thing was just not responsible for any of the instrumentation. And so moving on from that, our design specifications that we made, one of the big things that we talked about throughout the class was just how level can we make this trailer, and putting a range of values that would be acceptable on that. So we ended up choosing the plus or minus 3 degrees of the trailer, and we'll get into how that looks in our validation section. But the next thing was we wanted to lower the setup time from Dr. Soy's current setup time for these 2 towers, which is roughly a day to 2 days, and changing that down to an hour just to be able to collect more data and make it easier to move it from place to place. The next 2 things are specific measurements that we had to achieve. The first being, in order for this to be road legal, it has to be less than 13.7 feet according to the Wisconsin State Legislature. And so we chose 13 feet just to give us a range of factor of safety on that. And then the NDVI sensor needs roughly 2.6 feet from the edge of the trailer, just so that the range that the NDVI sensor picks up, it does not pick up the bed of the trailer.
As Jack mentioned, Dr. Soy has done some previous research on this, and from that, he actually provided us with a tower that he used in the past, as well as the trailer Jack had mentioned. The tower that Dr. Soy used in the past was a fixed tower, like his other ones. And so the first thing that we wanted to do with this, we wanted to make it adjustable. And so to do that, we turned it into a telescoping tower. And to do that, we had to remove the threaded bit that the center mast screwed into, and we made it so that that center mast could slide up and down through the tripod center. To make it slide, to make it move, we added this winch shown in blue here. And then additionally, we added a pulley to the bottom of that center mast. And from the winch came a cable that looped back up around through the pulley and back up to the other side. By doing this, that mast is able to slide freely and with very little effort from the operator. Additionally, as a way to make this more rigid, since we removed the threaded bit that added the rigidity for that center mast, we added this tube block. It is shown here in that pink there to the bottom of the tripod centerpiece. You use Allen keys to tighten this, and this prevents the center mast from moving at all within the actual tripod center. It additionally does not let it turn at all, and then it also takes the load off of the pulley, which is just safer for the operator, as well as keeping the center or the cross arm where we want it to be for data collection. Then, as Jack mentioned, leveling was essential for this. To do that, we made a slight modification to the tower itself. We added these turnbuckles to each of the 3 legs. That was a way to kind of fine-tune the level of the tower itself. And then to level the trailer as a whole, we added a camper jack shown here to each of the corners. We mounted that onto a plate, which was then mounted to the trailer itself. That jack uses a drill to run it in and out, which is more efficient than having to kind of hand crank that, all in the goal of lowering the setup time.
Yeah, cool. So moving into sort of how we validated this design, the main thing, in order to validate the leveling, we ran a system of tests. So we ran multiple different iterations of this test, which each iteration was a 5-minute time window where the trailer started out completely unlevel, and none of the jacks were on the ground, and the one of us had 5 minutes to go in and level it to the best of our ability, and then at the end of it, we took 2 readings, one of the length of the trailer, just reference to how out of level it would be, and then the next being the width of how out of level it would be, and that was done through the use of a digital level. And in these iterations, we were able to create a 95% confidence interval of where the mean would typically fall if you were to go out and just do this one random time. And we were able to find that the range that the mean fell in is very small and very much smaller than the design specification that we have created. So ultimately, that passes our design spec. But here you can see just the different averages from our tests that we were able to do. The next table here is the rest of our design specs that we made. These are just one-off measurements that we had to do in order to validate the design. The first just being the average setup time of the whole system. So Max and I ended up doing a couple of runs of this and just taking the average time, and that's shown here. The next being the height of the system while driving. So this is when the winch has the centerpiece all the way down, and we measure that from the floor to the top to make sure that it was below our 13 feet, which it is here, which is 12, which is less than that, so that design spec passed. Then the next being the NDVI width, and we were able to make that 3 feet. And then also the cross-arm deflection, which this was measured through the use of a load cell where we were able to apply a specific amount of force a certain distance away, and we used that digital level once again to create a degree out of level, and then created then we did some trigonometry equations just in order to determine what that deflection is in reference to perfectly straight to not.
Safety, we have determined 3 top safety failure modes. The top 2 are kind of similar. Tower properly secured once raised, and then operator injury during setup. Both of these kind of impose a risk towards the operator. And then the third one would be a sensor's fall from the cross-arm deflection. As a way to mitigate these top 2, we created a manual shown here in this binder. This manual provides like a step-by-step setup. As long as you follow it and don't skip steps and stuff like that, the system should work as it's supposed to and safely. And then to mitigate that deflection, we added the tension wire from the top down to the crossarm. This has a turnbuckle there, so it's adjustable to always maintain level of that crossarm, which would mitigate any risk of these falling off from it being out of level. Future work, some next steps that we determined would be very helpful in this project. We would add a second 2-block to the top of the tripod centerpiece. Doing so, it would add more rigidity, more stability to the center mass, the tower as a whole, and just kind of take the load off of the one on the bottom. We also determined that we could probably remove the turnbuckles. We achieved a much higher interval of confidence for leveling the trailer, and additionally, we did not believe that the tensioning cable would provide as much adjustment as it does, and so we just think those are not necessary at this point in time.
And then the final thing that we would do just to improve our design would be increasing the diameter that we chose for the crossarm. When we were making that decision, we were more concerned about the end fittings of the sensors themselves, where if you're able to make the crossarm have a larger diameter, then the deflection is not as bad, which then also would not have to include that tensioning cable on top of it. So
Here are
this is our
references.
references QR code, and then we can show you how the system works if you'd like to.